Hey, good morning all. I am Raghav Lohar from Evo 3D, and today I'm going to talk about what happens when 3D printing grows up. So most of us have been introduced to additive manufacturing through like desktop solutions, more like desktop-based 3D printers. But as time grows up, we have the desktop printers have been really useful because it enabled creativity and allowed us to design freedom. So just to introduce, Evo 3D has been supporting that desktop revolution because prototyping has been made quite easy to go ahead with to show us the most creative kind of desktop printers, a lot of varieties, ease, and a lot of use. But with time, we've been asked one question that what happens when the print size is quite big, when the parts are big, when the part is used in construction solution, and when the outputs are quite mission critical. So that's where Rapid Fusion comes in. Rapid Fusion specializes in large-scale 3D printers with the use of additive manufacturing, robotics, AI, and automation. And with the use of robotic arms and larger calculate solution, we've been supporting industrial application across various industries such as aerospace, marine, automobile, and construction sector as well. So, why scaling matters? Scaling isn't just about the size, but again, it's about speed, it's about customization, and it's about efficiency as well, because only the size won't do it, if you want to print bigger parts. So, from if I talk about the next step where we are headed, so from desktops to industrial thing, there were a lot of size constraints, like for the desktop printers. There were limitations on the material side of things, and the production output was more limited towards like just the prototyping bits, and the customization again was a thing back then. But as we move further, we have got requests for larger bid volumes. So when the bid volumes increases, we need to work closely on the design because these are quite critical components, and it has got complex geometries. The material has been quite lighter because continuously there has been development in terms of research. So now the material what we've got will be about lighter materials, and we have seen applications where like people are building boats out of it, like the big boat, USVs, UAVs, drones, and so on. So strategically, again, when we move further out the line, the robotic automation gives a design flexibility. So most of the 3D printer or the desktop printers, what we have been seeing across, are more like country-based, and with the robotic arm, it gives more of a design solution. So we're not only just talking about additive manufacturing, but it has also got subtractive capabilities. So it comes with a billing tool as well, where it enables the application and you get a finished part. So can the teams as well as the companies working on larger components can directly get a finished product straight out of those 3D printer. And the integration, there's a system like a turnkey solution and the system which is associated with that, a lot of components working together simultaneously. So the challenge is, like, there are some engineering challenges which we need to address, like the structural stability at scale, thermal management, and the layer bonding consistency as well. But there are some operational challenges as well. So as operational impact is more on the distribution side. It reduces the lead time. So the main thing is now we work a lot with the tooling, mold making. So when we talk with the teams, we usually hear that it takes months to get through the design stage to the production. But when they need to have a small design change, it impacts the overall supply chain, and the lead times are just not manageable. So overall, with this tech, it reduces the lead time, localized supply chain. So you don't need to rely on different supply chains for component coming from here, there, can get everything in-house and in one go. So some of the challenges with what happens, I take this video so it will give you an example of how it looks like. So this is our solution in action, where you can see the extruder capabilities around it. It is capable of extrusion of around 17 kilograms per hour, and it supports a range of material, like you can print carbon fiber, glass fiber, recycled materials, and get rock finish. So this is one of the construction modes what we've been worked for, and usually it takes like 3 to 4 months for this, but we managed to print this in within 3 days. And again, if I talk about the finished part on the milling side, it took 4 more days. So within a week, we were ready with the final solution. Now, some of the other bits, like as things are progressing, it's getting involved, there's a lot of new things coming up. There's an organizational challenge as well. So the teams at the moment are quite used to the ongoing technology or the process what they've been following. So there's a learning curve for the teams as well. And moreover, there's capital investment as well, because as the printer grows bigger, there's always well. So there's the requirement of some capital investment as well, which is like an upfront cost for most of the companies. So when we talk about bigger companies like in aerospace sector or in marine, some of them would be really useful, because when they see there is a long-term return on investment what they've been doing, it reduces a lot of time. But to support that, there's some operational challenges as well. The workflow needs integration. It needs to integrate well within the team. The team members need training as well, because the kind of software that's being used when the part is quite big, what is the print strategy that they're gonna use, what material they're gonna use, and how they're gonna do the post-processing. Because most of the time, if you miss during the post-processing, the whole of the print might get damaged as well. However, there is a trade-off as well. So if we want to save time, speed up production, along with precision, there was a trade-off. But as the technology has been evolving, we see that gap closed up. So if I move down, these are some of the applications as you can see out here. With a proper system in place, this is our gantry-based solution, where we have been printing USVs for like working along with the government agencies, some of the companies involved in the defense sector, and along in the middle you can see is the Swiss cell. So that's mounted on a robotic cougar arm. And the recent development what we have got is we have got a containerized solution, which is Cerberus. So Cerberus is a big, like you can say, a mobile factory moving. It can be deployed on site, where it is up and running within 20 minutes. It comes along with 3 heads. One is you can print with the filament, other is the pellet extruder, and it also comes with a milling head. So all of this, the operator can sit and basically container can be moved around, and considering the situation, what's going at this point of time in the world, this is our recent launch, which has got real interest. And most of the complex geometries as well, we've been able to do that. Now, there's some real lessons we are learning with the development of this. What needs to be done is like the scaling on an industrial scale. So we have been continuously working on our print strategy, as well as how best we can get the finished part, reduce the overall cost, because anyway, the cost matters to the companies whatsoever they are involved in such a big project. So the future of big additive. So how do we see this moving further? There's a convergence of robotics. A lot of robotic components has been used. AI optimization. So AI has been both, as like in the previous guest talk, we were discussing that there's pros and cons for AI coming in place, like some of the misinformation coming in. But if we are using it productively, it's been helping us out to optimize it, and it doesn't need many team members to be involved. So we have developed a kind of an AI assistant for printing. And while slicing the software, if someone in the engineering team has got a question, they don't need to email and get back to the team or higher management to ask for like what do I do next? Or again, like it takes a few days when they get answered. So we built an AI assistant, Bob, which continuously assists the technician or the engineer who is operating the print. And alongside that, we do a light thermal tracking as well of the bit with calibration. Advanced materials being used, so more of the focus is now on the recycled materials, how best we can reduce those waste that's going off. And day by day, like even for aerospace applications, I've seen like really lightweight materials, which is great. So the extruder, what we have is what we have built, and everything what is being developed is made in the UK, and we've been working and we've been got a grant with the UKRI to build Kent-based solution, which was Medusa. And if I speak about let's say some of the further expectation, what we can expect with this kind of technology when it's evolving is larger parts. Now, for some of the applications, when if we speak about boats, when people are on it, or if it's an aerospace application, there's a lot of regulations in aerospace that needs to be fulfilled. So earlier, there were a bit of resistance from the team as well too, because it's a lengthy process, as well as whether it's reliable, it needs testing, and it needs to prove itself. But with time, the industry has been adapting. Companies working on big sectors, they are quite interested, as well as we've been getting a lot of projects where like they want a final solution out of it. And hybrid manufacturing environments is like really growing up, because everything is in one place and they can get it going. So, closing thought, big 3D printing is big transformation. So if I say how big we have printed parts around 3 to 4 meters big, which were quite complex. Angular, we have printed on an angle as well. So we printed 45 degrees with the extruder. The extruder is capable of reaching like a temperature of 450 degrees. It supports a wide range of abrasive materials, can print carbon fiber and fish. Moving further down the line, the teams as organizations try to cut cost and move further down the line. It's moving towards more like a smart production, when the team is no longer like 200 members involved in one part. It's just 2 to 5 people who are designing it, printing it, and getting it ready. The supply chains disruption is going on due to world affairs simultaneously. So to make supply chains more reliable, this is a one-stop solution. It opens up new design possibilities, and there's endless solutions and endless applications as we keep on researching and we keep on growing. So we are continuously involved. We got our engineering team as well as research team continuously working on to find out the best possible ways to minimize waste and get great designs and basically build big. So this is how, and this is what's happening at the moment, when like 3D printers have moved from desktop to on an industrial scale for scalability. Thank you, and you can explore our capabilities. So Evo 3D, we got a range of 3D printers with overlap, reality, grid boards, SharePod, small, all sizes of printers. And along with that, if you have a project where like a bigger application is required, we also work on the printing services as well for bigger parts, because it's not necessary that we go ahead with the hardware, but we provide the services. We want to prove what the hardware is capable of, and once you see there's advantage to that, then obviously it can move further down the line. So you can contact us, and yeah, any questions related to this, most welcome, and thank you so much, everyone. Got about 5 minutes for questions. Guys.
What's the biggest bench trick you tried to?
So,
What's the biggest bench sheet that you threaded?
what's the biggest, sorry?
Bench you got.
Oh, right. I can say bigger than my height. So we recently printed a USV, and it was more on for a pilot project, I'd say. And if I give you some insight, we are building some sort of UAVs as well, like kind of some sort of drones, and much more. We need to own that. So to answer that question, yeah, it was bigger than my height. Any other questions from anyone? Yes.
It's when you scale up on resolution. So what's the expectation? Does people ask you to have a like quite fine resolution, or they happy to go with a high resolution scale?
Very English.
Yeah, in test resolution.
So in terms of
Layer height.
yes. So there's a wide range of so depending on the application again, it varies in design, but the nozzle size what we have got is from 12 to whenever, and like depending once the base is developed and it's already up, it picks up the speed and it can extrude up to 17 kilograms per hour. So like you can print really quick, but again, like there are different print strategies as well as the design, the configuration. So on. There's a lot of constraint to that. So yeah, but we get some really good results. So if you visit the website, you'll see a lot of stuff what we have produced.
So, everybody's.
I think we've got time for one more question. The sound the room. But well, okay, let's give our speaker another round of applause. Thank you very much.